Hello, class. My name is Jenny McNutt, and I am your GCC instructor. So welcome to our virtual classroom. We're actually in my dining room, and I had my husband install a whiteboard for me and just drill that. And so this is going to be our classroom setting for all of your learning videos. There are some advantages if this is the first time you've done a virtual class, especially a virtual math class. There are some definite advantages to having this type of presentation, this direct instruction. One of the great things is that you can pause the video. And so sometimes when you're in a classroom watching a math class and the teacher maybe goes too fast, or you blinked and you missed something, you're never quite able to catch up and you feel lost for all of the remainder of the steps. And so hopefully some of those things you'll find that this is to your advantage. Today's lesson is section 4.1, and I know the lighting, this is kind of my sample lesson, so hopefully it comes out okay. Maybe you guys can, well, by the time you see this, I might have already made the rest of them, but if it's a little dim, I'll kind of play around with that. The lighting here has a lot of glare. The whiteboard itself has a lot of glare. So I'm working. As the class improves, hopefully so will the quality of my instruction. So like I said, this is section 4.1, and we're going to be talking about exponents and their properties. So give me just a second to make sure that you can see that in the screen. I'm going to run out of camera real quick. Yeah, it's not the straightest thing I've ever seen, but again, I will improve with time as well. Instead of just watching the video, if this is really new for you, maybe it's been a while since you've been in a math class, I would strongly encourage you to pretend like we're actually in a classroom. Have a spiral or some type of notebook if that's your learning style. I've had students take notes on their laptop before, so whatever your natural learning style is, I would encourage you to stick with that. And so whatever I write down on the board, I would have you write down in your own handwriting so that you can go through the motions of one step to the other. And I very firmly believe that writing it out makes that connection up to that memory, those memory centers, even more secure. All right, so first thing we're going to do is review. You're always welcome to go check the vocabulary, kind of preview the section for the day. My Math Lab has the online version of the textbook, so I don't always go through all of the vocabulary words that you might see, knowing that you can go back and reference them. We don't take vocabulary tests, but as you move through the course, it will be assumed that you know some of that basic vocabulary, variable, exponent, so that you'll see me reviewing some things here. But I don't always catch every word, and some things I think you probably are already familiar with. So x to the third means x times x times x. And so when there's 1, 2, 3, please recall that if there's no exponent right there, there's a little implied 1. And I've definitely had some students that will add that in, and that just makes them more comfortable. Feel free to do that, even if you were, well, if you're going to answer on My Math Lab, you're probably not going to be able to put the 1. But when you're working out problems on the tries and things like that, there is an implied 1 right there. So 1, 2, 3, x to the third. This guy right here is called the base. And this one right here, that's the exponent piece. So when I have those vocabulary words, that's what I'm referring to. All right, we have 4 rules to go through. In section 4.1, I'm a little concerned about my marker quality. So I am going to switch to a marker that might have a little more contrast here. Our first rule is called the product rule. And our product rule says this, and all of this is explained for you in your textbook as well. So the official rule looks like that. If you have a to the m and you multiply that by a to the n, then you add those exponents together. Please notice that in this case, your bases have to be the same for this rule to apply. And so let me show you why it works. Okay, so what that rule is saying is that if we have x to the fourth times x squared, that would be x to the sixth. Here's why it works. I just had up here on the board that x to the third was x. So x to the fourth is going to be x times itself 4 times. X squared is going to be x times x. Well, how many times did I write x down? 6 times. So imagine those little exponents right there. 1, 2, 3, 4, 5, 6. X to the 6. So that's why it works. So let's use that product rule in some examples. So the next part of our notes, I just have a few to kind of run through. So example A. Sometimes I use the examples from the book, and sometimes, or I'll do something similar, sometimes I make up my own. I make sure the level of difficulty matches the book for sure. All right, so you'll see in this first example here, remember the bases have to be the same. So we are only going to combine the x's with the x's and the y's with the y's. I would encourage you to maybe color code your notes. Also, if that's helpful, have a couple different colors, and so the y's match up and then the x's match up. And so if I add those exponents, 3 plus 6 is x to the 9th, 5 plus 2 is y to the 7th, and that's my final answer. Your bases do not have to be variables. Your bases could be actual numbers, actual constants. And so in this case, the same rule applies. If the bases are the same, we can add those exponents together. On C, we can also have a quantity. So because of the parenthesis right there, it's the whole quantity, x plus y, that is being taken to the power. We know there's a 1 right there. 1 plus 3 is x plus y to the 4th. So that's a few examples of the product rule. The next one, while I erase, if you guys want to write down, the next one's going to be the quotient rule. The quotient rule. And it's similar. Just like product means multiply, and we add those exponents. Our quotient rule, the word quotient means to divide. And so the opposite of add would be subtract. So the rule in its most general form looks like this, which all those letters can definitely be confusing to some people. Oh, please note, sometimes, oh, I did an okay job. Sometimes I toggle between an uppercase and a lowercase letter, and I don't intend to be confusing, so I will try to be consistent, especially since you can't ask me for clarification. So I will work on that as well. All right, so here's some examples. We have a to the 6th over a squared. And so the reason, oh, I didn't go over the reason, bear with me. I'll do that with this example here. I should have explained it right there. So a to the 6th means that we would have 6 a's. A multiplied by itself 6 times. 1, 2, 3, 4, 5, 6. A squared means we would have 2. Don't get confused that I just put a dot right there. Just happened. You could put a dot on all of them. Now remember, anytime you have a factor over itself, that factor has a value equal to 1. So what that means practically is that you can cross that out. So those cancel, you're left with a to the 4th power. Now, no one would want to write out a to the 20th and then a to, say, the 11th. Like, you wouldn't want to write all those a's if that was the problem at hand. And so notice how this is a really nice shortcut. 6 subtract 2 is just a to the 4th. So that's why the rule works. Don't forget, it can work on quantities as well. I don't have as many examples for this one. My only other one is something like this. Sorry. This is going to happen. I'm going to make mistakes throughout here. And then you kind of go, oh, do I go back and redo the whole thing? Videos used to be my #1 fear. The way some people fear public speaking. I got over a lot of that just becoming a teacher, but I've always just really struggled making videos and allowing myself to be on video. So definitely something that I am overcoming. So please note that if I fumble or something, I'm overcoming my fears as well. Maybe you are or had to challenge yourself recently in all of this strangeness. So we have 10 here, we have 3 here. Notice that those are in parentheses. So it's that whole thing that's being raised to the 10th power. So we are going to have 4a quantity to the 7th because we're going to subtract those exponents. All right. You guys want to write down then? Oh, I do have a few more. Oops, guess I should have turned the page. Let me erase. Okay, I was hoping I had written some more down. I can think up examples pretty quickly in my head in an online setting or in an in-classroom setting. But again, it goes back to the video thing, so I need to make sure I'm ultra prepared here. All right, so let's look at this one. We have 4/6. That's going to work just like a normal fraction would. So you can reduce this part of the fraction just like normal. Both of these numbers are divisible by 2. So if I divide that by 2, 2 goes into 4 2 times, 2 goes into 6 3 times. So I'm just going to go ahead and write that. So we'll get started on our fraction. The 2 stays in the numerator, the 3 stays in the denominator. All right, now I'm going to look at just the x's. So right there we have x to the 10th and x to the 8th in the bottom. Use that rule and subtract those to x squared in the numerator. We have y to the 3rd over y to the 1st. Remember, that might be where it's helpful to kind of write that down. 3 subtract 1 is y squared. So the only thing in the denominator is that 3. All right, see. Okay, oh, I switched them because we're not ready for this yet. Let me switch these exponents real quick. You might want to write in pencil if you're kind of doing this real time, because even online I'm making mistakes. All right, so 5 to the 8th over 5 to the 4th, and when we subtract those exponents, 8 take away 4 leaves 4, and so we're just right there. All right, let me check that I still have battery on my phone. Yep, we're still going, good deal. All right, so that's the second one. We only have 2 more and we're done with section 4.1. The next one is called the 0 exponent rule. And the 0 exponent rule in its most general form is simply this. Anything to the 0 power is 1. So it's hard to remember. It seems easy enough, but sometimes it's hard to remember. And there are little tricks that go along with this that are easy to forget. Here's why it works. If we have something over itself, we just discussed, or I was just kind of reviewing with you, that any factor over itself directly cancels itself out and is equal to 1. However, We also know that if I have a squared over a squared and I apply the quotient rule, I'm going to subtract those exponents, and 2 take away 2 is 0. So if this equals a to the 0 power, that same thing equals 1. If both of these items are equal to the same thing, they must equal each other. So it's called the transitive property. And so if I put those two items together, then a to the 0 equals 1. So that's why it works. Here's how it's going to look in examples. All right, so it could be a number, base, a numerical base, still be 1. It could be that part of your term is taken to the 0 power, and so you want to be very careful. Excuse me. You want to be very careful because x to the 0, this part right here is not taken to the 0 power. So 5, this part right here is equal to 1, so this whole thing is equal to 5. Oh my goodness. All right, let me pause real quick. Hold on. So sorry.